Good day everybody, we've been given this question. Let me state the question. If we have a function heading from R to R, be continuous, and it satisfies integral 0 to pi over 2 f of sine 2x times sine x dx plus alpha times 0 to pi over 4 f of cos 2x times cos x dx is equal to 0, then we are asked to find the value of alpha. So foremost, what I wish to do is I will take I1 to be equal to integral 0 to pi over 2 f of sine 2x times sine x dx. I2 is equal to integral 0 to pi over 4 f of cos 2x cos x dx. Next I will consider I1 is equal to integral 0 to pi over 2 f of sine 2x sine x dx. Now what I wish to do is I would like to set x being equal to pi over 2 minus x from the property of integrals, or I would say from the property of definite integrals. This is an acceptable substitution. So this can be rewritten as f of sine of, you have a 2 there, 2 times of pi over 2 negative x, and sine of pi over 2 minus x times dx. Okay, you have a parenthesis there. Now when we have the limits x is equal to 0, the change occurs here, but we would have x is equal to pi over 2 here, right? But apparently when you have this dx will have a negative dx there. So because of that, it's going to be 0 to pi over 2. So this is just your side information. We don't need this, but just for your understanding. So the point I wish to make here is by taking x is equal to pi over 2 negative x, we are not changing the system. So let me just work on sine of, or I would say sine 2 of pi over 2 minus x. This is rewritten as sine of 2 times pi over 2 negative 2x, which is equal to sine of pi negative 2x. Now I am using sine of a negative b formula, which is sine a cos b minus cos a sine b. So by this formula, sine of pi negative 2x is going to be sine pi cos 2x minus cos pi and sine 2x. Now cos pi is negative 1, so this will produce sine 2x, so this goes off, right? So that is for this function f of sine 2 times of pi over 2 negative x. Now we need to handle sine of pi over 2 negative x. So this is going to be sine pi over 2 cos x minus cos pi over 2 sine x. So this goes off, so giving us cos x. So therefore this is going to give us cos x. So sine of pi over 2 negative x is going to be cos x. So therefore if I were to take this as 1 can be rewritten as I1 is equal to integral 0 to pi over 2 f of sine 2x times cos x times dx. Okay, so this is my new, or I would say this is going to be my, probably I'll mention it as 3. Okay, so this one I will take it, I'll take this as say 1, this one as 2, this one as in fact we don't need to have a number for this, right? So this one is going to be my 3. So I'm going to add 1 and 3. You see this 1 and 3. So let me write that down. Adding 1 with 3 we get. So I and I, that's 2i, is equal to, this is going to be the first component, 0 to pi over 2 f of sine 2x times sine x dx, positive integral. This is the next one, 0 to pi over 2 f of sine 2x times cos x dx. Okay, I hope you are catching it. Okay, now this can be rewritten as 0 to pi over 2 f of sine 2x. Now I can take sine x and cos x as a sum times the dx. So this is what you got, and you have 2i. Now from the property of integrals, I can actually rewrite this as 2 times integral 0 to pi over 4. Pi over 2 is here, so this is going to be 2 times pi integral 0 to pi over 4. So this is f of sine 2x times the sine x positive cos x times the dx. I'm going to take this as 4. Now you have 2i on the left hand side, so 2 gets cancelled, giving you I1 is equal to 0 to pi over 4 f of sine 2x times sine x plus cos x times the dx. Okay, so I'll take that as 5. Now let me consider I2. What is my I2? I2 is 0 to pi over 4 f of cos 2x times cos x times dx. Now let me set x to pi over 4 negative x. So cos 2x, cos 2 of pi over 4 negative x will become cos of pi over 2 negative 2x. So this is going to be cos pi over 2 cos 2x plus sine pi over 2 sine 2x. Now this one goes off, so this will give you sine 2x, right? Now similarly, cos of pi over 4 negative x, this is going to give me cos pi over 4 times the cos x, negative is there, so it's going to be positive sine of pi over 4 sine x. Now cos 45 is 1 over root 2, right? So this is going to be 1 over root 2 times cos x plus 1 over root 2 times sine x. I can take root 2 out and rewrite this as sine x plus cos x divided by root of 2. Okay, so therefore the above system, so this was our 2, right? So I can rewrite 2 as I2 is equal to integral 0 to pi over 4 f of cos 2x. F of cos 2x will become f of sine 2x, and cos x will become sine x positive cos x divided by root of 2 times dx. Now this is going to be our 6. Now the question, if you were to go to the question, see, the main issue that we have here is the limits. This is 0 to pi over 2, this has been given as 0 to pi over 4. and this is in sine. As far as the integrand is concerned, this is in sine 2x, this is in cos 2x. So our objective is to change this to reflect this. So that is what we are trying to do, and we have achieved that. Now, actually, what is this? If you were to see this, this is exactly, I'm going to rewrite this, I2 is equal to, now this entire integral quantity, just watch this entire integral quantity. This entire integral quantity is reflected here. You see here? Isn't it? So what is this? This is equal to I1. So with the exception of 1 over 2 there. So it's going to be 1 over 2 times I1. So this I1 to be as root of 2 times I2. Okay, fair enough. Going back to the question. If you go back to the question, let me show you the question. See, this is the question. Right, if I were to take this as, in fact we took this as I1 and we took this as I2. So I1 plus alpha times I2 is equal to 0. This is exactly what has been given in the question. So from the question we have I1 plus alpha times I2 is equal to 0, which means I1 is equal to minus alpha times I2. So if I were to take this as 7 and if I were to take this as 8, comparing 7 with 8, what do we get? We get negative alpha is equal to root of 2, which means alpha is equal to negative root of 2. So this is the correct solution. Thank you everybody. Please like, share and subscribe.